Ladies and gentlemen, imagine standing at the very edge of human endurance where the wind howls like 1,000 angry wolves and the temperature drops so low that metal becomes brittle and diesel turns into jelly in the tank. This is not some distant sci-fi fantasy. This is the brutal reality of Antarctica, the coldest, driest, windiest, highest continent on Earth, a place where survival itself is an engineering challenge, and wherein the late 1950s the Soviet Union decided to throw down the gauntlet against nature and against their Cold War rivals by building what would become one of the most insane, ambitious, and ultimately successful overland machines ever created, a rolling armored apartment on tracks that could cross thousands of kilometers of featureless white hell. Carry scientists live in sub-zero isolation for weeks on end and return home with data that would rewrite maps and challenge American dominance in the polar regions. This machine was called the Kharkovchanka, the woman from Kharkov, named after the Ukrainian industrial city where it was born, a 35-ton beast that combined the rugged chassis of a main battle tank with the insulated, pressurized comfort of an aircraft cabin, and turned the impossible task of Antarctic exploration into a gritty Soviet success story. While the Americans had tried and spectacularly failed with their giant snow cruiser a decade earlier, the Soviets learned from those mistakes, iterated relentlessly, and built not just one vehicle, but an evolving family of machines that served for decades well into the modern era. This is their full epic tale, from the geopolitical sparks that ignited the race to the final monuments still standing on the ice today. Let's go back to the beginning of it all, the mid-20th century, when the world was still recovering from the devastation of World War II, and the two superpowers, the United States and the Soviet Union, were staring each other down across every possible frontier, from space to the depths of the ocean, and yes, even to the bottom of the planet. Antarctica had long been a place of mystery and myth. Explorers like Amundsen, Scott, and Shackleton had reached the South Pole in the early 1900s, but large parts of the continent remained blank on maps, unvisited by humans, and largely unclaimed until the late 1940s, when the geopolitical game changed dramatically. In 1948, several Western nations, including the United States, Britain, Australia, France, Norway, Chile, and Argentina, sat down and essentially tried to divide up the Antarctic pie, drawing sectors like slices of cake radiating from the South Pole, each claiming a portion based on historical exploration, proximity, or strategic interest. The Soviet Union was conspicuously not invited to this discussion, which infuriated Moscow. The USSR saw Antarctica not just as a scientific curiosity, but as a potential strategic asset, a place where ignoring their exclusion could mean losing face in the global prestige contest and possibly missing out on future resources, mineral deposits, freshwater and ice form, or even military positioning in the southern hemisphere. So the Soviets responded in classic fashion. They ignored the Western claims entirely, declared their own right to explore and occupy parts of the continent, and set about proving it with action. In 1955, they formally established the Soviet Antarctic Expedition SAE, a massive logistical operation involving ships, aircraft, and hundreds of personnel under the scientific umbrella of the International Geophysical Year (IGY), which officially ran from July 1st, 1957 to December 31st, 1958. This was one of the largest coordinated scientific efforts in history, involving 67 countries, studying everything from auroras to cosmic rays, ocean currents to glaciology, and Antarctica was the crown jewel, the last great frontier where new discoveries could be made and national pride it could be showcased. The first Soviet ships arrived in Antarctica in early 1955, unloading equipment and personnel at the coast near what would become Mirny Station, named after the research vessel that brought them there. Two small bases were quickly set up, Mirny on the coast and another inland outpost. But mobility quickly became the biggest headache. The Soviets brought with them a fleet of standard military trucks, GAZ and ZIL models left over from the Great Patriotic War. These vehicles had performed miracles, hauling artillery and supplies through mud, snow, and battlefields across Europe and Asia. But in Antarctica's deep, soft, powdery snow, they were hopeless. The wheels dug and spun uselessly, and the trucks sank axle deep. Within minutes, the crews quickly learned that wheels were useless here. What was needed were tracks, wide tracks that distributed weight and gripped the snow like snowshoes on steroids. Luckily, the expedition had the foresight to include a handful of agricultural tractors, simple DT series crawler tractors designed for plowing fields in Siberia, In Ukraine, these were slow, cumbersome, had open cabs with almost no protection from the wind and freezing temperatures, but their metal tracks chewed through the snow provided excellent flotation and allowed them to tow heavy sleds loaded with fuel, food, scientific instruments, and building materials across dozens of kilometers. It was a crude solution, but it worked well enough to prove the concept. Tracked vehicles were the only way forward. The Soviets realized that if they wanted to push deeper inland, establish more stations, reach the South Pole, and conduct serious scientific work, they would need purpose-built machines capable of operating in conditions that would destroy ordinary trucks, or even standard military half-tracks. Temperatures routinely dropped to -50, -60, and even -70 degrees Celsius Fahrenheit equivalent, making rubber seals crack, batteries fail, and diesel fuel gel into a solid mass. Navigation was another nightmare because they were so close to the magnetic South Pole. Ordinary compasses became unreliable, spinning wildly or pointing uselessly. The landscape was completely featureless, endless white plains with no hills, trees, or rocks to use as landmarks. Blizzards could reduce visibility to zero for days on end, trapping crews in whiteouts where they couldn't tell sky from ground. Radio communications were plagued by ionospheric interference, especially during solar activity, and the high altitude on the polar plateau above 3,000 meters meant thinner air, lower oxygen levels, and engines that struggled to breathe properly. The first expeditions used dead reckoning celestial navigation when the sky was clear enough and constant radio checks with coastal bases, but it was slow, dangerous work. By 1957, after 2 seasons of painful experience, the expedition leaders sent urgent messages back to Moscow: "We are ill-equipped, the vehicles are failing, the men are suffering, we need specialized machines designed specifically for this environment." The response from the Soviet leadership was swift and ambitious. They turned to one of their premier engineering centers, the Kharkov Transport Engineering Plant in Ukraine, a facility that already produced heavy artillery tractors based on tank chassis and had experience with both military and extreme climate vehicles. The directive was clear: design and build a vehicle that could serve as a mobile research station, a self-contained habitat that could travel long distances in extreme cold, carry large payloads, support a crew of 6 to 8 for weeks or months, allow internal engine repairs without stepping outside, and most importantly, survive and thrive where previous attempts had failed. Drawing inspiration, ironically, from the American failure, the Soviets studied the Antarctic snow cruiser, a massive 35-ton vehicle built in 1939 by the United States for Admiral Byrd's expedition. That vehicle had 10-foot-high smooth rubber tires meant to float over snow like a boat on water, but the tires had no grip, sank, or spun uselessly, and after traveling only about 92 miles, much of it in reverse, the snow cruiser was abandoned, left to be swallowed by the ice. It became a symbol of what not to do: wrong tires, no tracks, poor insulation, engine outside the cabin requiring dangerous external repairs, limited living space. The Soviets took note and decided to go in the opposite direction: tracks, wide, low-pressure tracks like those on tanks, but even wider for better flotation, an enclosed insulated cabin large enough to live in like a small apartment, with bunks, kitchen, toilet, workshop, and laboratory space, and crucially placed the engine inside the living area so mechanics could work on it in shirt sleeves without risking frostbite. The cabin would be heated continuously, drawing from aircraft design principles because airplanes already flew at high altitudes and temperatures far below freezing, with pressurized heated cabins that kept passengers alive. The Kharkov engineers had only 3 months to design and prototype this monster, working around the clock. In late 1958, the first Kharkovchanka, officially designated as Object 404S, rolled out of the factory gates. It was a beast, 35 tons fully loaded, 8.5 meters long, 3.5 meters wide, 4 meters high, sitting on an extended chassis derived from the AT heavy artillery tractor, which itself was based on the ubiquitous T-54 main battle tank, one of the most produced tanks in history. The suspension used torsion bars, 7 large road wheels per side, 1 meter wide tracks with grousers for extra bite in deep snow, and a supercharged V12 diesel engine, the V2 series descendant, producing anywhere from 520 to 995 horsepower, depending on the tune and altitude. Compensation: the vehicle could reach 30 to 56 kilometers per hour on flat, hard snow, but in loaded Antarctic conditions, it cruised at 5 to 11 kilometers per hour, burning 9 to 12 liters of diesel per kilometer. When towing heavy fuel sleds, it could climb 30-degree slopes and tow up to 70 tons, making it perfect for dragging long trains of fuel bladders and cargo. The real innovation, however, was the pressurized insulated cabin, a 28-square-meter living space. That felt surprisingly like a small Soviet-era apartment, Kharkhovchanka style. It had 8 berths arranged in 2 tiers, a galley kitchen with an electric oven stove for hot meals, a small chemical toilet, a dining mess area, a navigation and radio station, a workshop bench with tools for repairs, and even a small scientific lab corner for processing samples. The walls, ceiling, and floor were layered with 8 centimeters of wool felt insulation sandwiched between metal sheets, reducing heat loss to only 1 or 2 degrees Celsius per day, even if the heating failed completely. Electric heaters powered by the main engine or auxiliary generators kept the interior between plus 15 and plus 25 Celsius, while outside it was minus 50 or worse. The engine was mounted inside the cabin at the rear, separated by a bulkhead, but accessible via hatches. This allowed mechanics to perform maintenance, tune-ups, and emergency repairs without ever stepping into the deadly cold, a life-saving feature. But it came with trade-offs: constant engine noise, vibration, diesel fumes that had to be carefully vented, and occasional soot buildup that made the air inside smell like a garage. 5 of these machines were completed and shipped to Antarctica aboard the diesel-electric ship Ob in late 1958. They arrived in time for the summer campaign, January-February 1959, and immediately proved their worth at Pinerskaya Station, an inland outpost several hundred kilometers from the coast. The vehicles demonstrated they could maintain warmth, move reliably, and keep the crew alive and productive in conditions that would have crippled lesser machines. By February, 3 Kharkvchankas set out for Vostok Station, the most extreme outpost planned at the geomagnetic South Pole, nearly 1,400 kilometers inland, where temperatures would later hit a world record minus 89.2 Celsius. The journey was grueling but successful. The machines plowed through sastrugi hard, wind-sculpted snow ridges, crevasses hidden under thin snow bridges, and sudden whiteouts. Yet they kept going. In September 1959, the big push began. The full fleet of 5 Kharkvchankas plus support at T-tractors departed from Mirny Station, heading for the geographic South Pole, a round trip of more than 5,400 kilometers across the polar plateau. The convoy towed long trains of fuel sled, scientific equipment, living containers, and spare parts. Every liter of fuel was precious because fuel made up 70 to 75% of all cargo moved in Antarctica. It powered the vehicles, heated the cabins, and served as the only reliable heat source in an environment where wood didn't exist and coal was impractical. The journey took 89 days through blizzards that reduced visibility to meters, crevasses that swallowed sleds whole, and mechanical breakdowns that tested the crew's ingenuity. Tracks through 160 pins in the first 870 kilometers, requiring field repairs in minus 60-degree cold. Engines overheated to 95 to 100 degrees above normal coolant boiling, despite radiators designed for thin air. Cabin temperatures swung wildly from plus 35 Celsius near the engines during heavy work to minus 10 when systems were shut down for fuel conservation. Yet the crews persevered. They stopped at intermediate depots like Komsomolskaya and Vostok, refueled, repaired tracks, rested, and pushed on. The final leg, 1,253 kilometers, was true terra incognita. No previous overland traverse had covered it. Radio contact with coastal bases provided moral support, weather reports, and emergency coordination. On December 26, 1959, 2 Kharkvchankas numbers 21 and 23, accompanied by an AT support tractor, rolled into the American Amundsen Scott South Pole Station. The Americans, who had flown in supplies and personnel, were stunned to see these massive red-painted Soviet machines appear out of the white horizon, flying both Soviet and American flags. The crews were welcomed warmly, given hot coffee, invited inside for meals, and allowed to rest. A brief moment of genuine human connection amid the Cold War frost. After 3 days of scientific exchanges, photography, and refueling, the Soviet team turned around and began the long return journey, arriving back at Mirny in early 1960, having completed one of the most remarkable Overland expeditions in polar history over the following decades, the Kharkovchankas became legends. They supported dozens of inland traverses, hauled thousands of tons of cargo, established fuel depots, visited the pole of inaccessibility, the most remote point on the continent, and linked coastal stations with deep inland outposts like Vostok and Concordia. Crews developed routines, sleeping in shifts, cooking communal meals, conducting science while moving, performing endless maintenance. The noise was deafening, the fumes sometimes overpowering, the vibrations rattled teeth, but the warmth, the safety, and the ability to keep going made it all worthwhile. Veterans like driver-mechanic Nikolai Grushinsky later recalled days of endless white, no horizon, no reference points, just following compass headings and sun shadows, endless cups of tea brewed on the galley stove. The crackle of shortwave radio bringing voices from home, and the profound silence when the engine was off under a sky filled with stars brighter than anywhere else on Earth. By the mid-1970s, the original Kharkovchanka design was showing its age. Fumes were a persistent health issue. Noise levels caused hearing damage over long missions. Track was high in abrasive snow, and the rear engine layout still limited forward visibility. So, in 1974 to 1975, the Kharkov plant rolled out an improved version, Kharkovchanka. This model moved the engine and driver's cab forward for better access and visibility, added auxiliary diesel generators so the main engine could be shut down periodically, reducing fumes and noise, installed better cooling systems for high-altitude operations, sealed more leaks in the cabin, improved track tensioning mechanisms, and upgraded the electrical system for more reliable heating and lighting. 3 units were built and deployed in the Antarctic summer of 1975 to 1976. They proved even more efficient, requiring less frequent stops and providing better crew comfort. A proposed third-generation vehicle based on the larger MTT chassis was planned in the 1980s, but the economic collapse of the late Soviet period and the dissolution of the USSR in 1991 halted further development. Still, the existing fleet soldiered on through the Russian Federation era, maintained by successive expeditions well into the 2000s. By the 2010s, newer vehicles like the Belarusian Vityaz DT-30P, articulated track transporters, and modern piston bully snow groomers began to take over the heavy lifting, but the Kharkovchankas refused to fade quietly. Several were retired to museums or used as stationary facilities at stations. One unit, number 22, was painstakingly restored, painted in its original red with CCCP markings, and now stands as a monument at Progress Station. A silent testament to Soviet engineering, grit, and polar ambition. Today, when scientists at Vostok or Concordia look at old photographs or walk past the preserved hulls, they remember the pioneers who crossed the ice in machines that were part tank, part home, part laboratory. The Kharkovchanka was more than a vehicle. It was a symbol of human stubbornness, ingenuity, and the refusal to accept that some places are simply too harsh to reach. In Antarctica's death zone, where nature tries to erase every trace of man, innovation, grit, and a warm cabin on tracks prove that even the coldest continent could be conquered 1 kilometer at a time. And that legacy lives on every time a new expedition sets out across the white silence, echoing the rumble of those original beasts that refused to be stopped by the ice, wind, or cold.